Hello everyone, it's May the 2nd. We're back again to handle today's LeetCode challenge. Alright, let's get right into it. Course schedule. Sounds familiar. I might have done something like this before. Okay, so there are n different online courses numbered 1 to n, okay? You're given an array courses where courses I equals duration and last day, indicating that the ith course should be taken continuously for duration, amount of days, and must be finished before or on last day. It will start on the first day, and you cannot take 2 or more courses simultaneously. Return the maximum number of courses that you can take. So we start from a duration, so this means it lasts 100 days and it must end at 200 or lower, smaller days. Okay? There are total 4 courses, but you can take 3 courses at most. First, take the first course. It costs 100 days, so you will finish it on the 100th day. Ready to take the next course on the 101st day. Second, take the third course. It will cost 1,000 days, so you will finish on the 1,100th day and ready to take the next course on the 1,101th day. Then take the second course. It will cost 200 days, and you will finish on the 1,300th day. The fourth course cannot be taken now since you will finish it on the 3,300th day, which exceeds the closed date. Okay. So we have a duration and we have an end time, right? And we want to squeeze in as many as possible. So the end date, if my end date, we can sort based on end date, right? We sort based on end date. That means we have a deadline for each class, and we start taking each class. If we end it on end date, that means there's no more room that we can do. So we're saying that we want to take a class that will end earlier than the end date, so we can scoop in an extra 100 day. But the end date is, so the first one is 200. Second one, if I go, it's going to be 2050, and then 1300, and the last one will go 3200, right? That's ordered by the end date. Actually, it doesn't really matter. Does the order matter? Well, it does matter. The ones with smaller end date definitely should be taken earlier, because a smaller end date, I think smaller end date needs to be taken earlier. Because if you don't take the smaller end date earlier, then you will not have a chance to take it. So we take the smaller end date first. What if we have end date? They are the same. They end at the same time. What if they end at the same time? And each time you're going to take one class, right? So you have to wait until a class ends, and then you can take the next one. Therefore, when a class ends with the smallest, shouldn't be just like the smallest end date goes first. If the end date is the same, then we take the one with a smaller duration, because a smaller duration means we can gain more. We will have more room to fit another class. That's like greedy, right? I'm trying to go greedy. We say smaller end date goes first. What if we don't go smaller end date? If we go a larger end date, we say that one will lead to a larger end date and then a smaller end date, instead of a smaller, strictly small to large. If we like swap it, what's going to happen is, actually it doesn't really matter. What matters is the duration. But I mean, yeah, and we can take 100 and take 200 and take 1000. Oh, that is not going to work, because if we take 100, 200, we have 300. Take that, that's 1300. I would take 100 and 1000, that's 1100, and then plus 200, and that will reach 1300. Which means we want to fit, right? Given the end date, like 3200, right? So that's the last end date. Ideally, we can fit everyone in it. If we can fit everyone in it, that's not necessarily true, because someone might not be able to fit. Bunch of classes where we either take it or we don't take it, right? So if we take it, then we have a new end date. And this order also matters, right? Order also matters. Of course, it should be the smaller duration should go first, because we have a larger duration and it's larger than the smaller, then we can never do the smaller. But if we do the smaller first, then we will always have a chance to do the larger, especially if the end date of these two is equal to the smaller. Yeah. So we say we go the smallest first. And then also with the end date. So again, I think it's like 3 and 2. Oh, 3 and 2 is not going to work, because it doesn't guarantee the first one is. No, it does not guarantee. So like 3 and 2 is going to return a false, because the duration is larger than the end date. The duration has to be smaller than the end date. So this is like a trivial case. I have a bunch of pairs. If a course fits, then it doesn't really matter, right? It doesn't really matter. I would take the smallest, then what? If I take the smallest, then everybody's end time. We can minus this, kind of find out. Like, we take 100 off, so 1200 here. try to fit a 200, which definitely does fit. Or we take 1150, it definitely fits this one as well. Or we take 3100, fits this one as well. We'll try to see 1150, if it fits this, it does fit. I have no clue so far. Continuously for this duration. I'll have a duration, I'll have an end date, right? Duration and end date. At any state, we have the current time. We'll have current time. So based on the current time and my end date, I can determine whether a course can be taken or not. And what we want is the maximum number of courses taken. Right? So we start, the time is 0. Right? The time point is 0, and we want to know the maximum at this time that we can take. So at this time, we can take all courses, doesn't matter. And once we take those courses, then I have the current time point, right? We're at 100, if we take the first one. And then at 100, then we try to see which one can we take. Well, we're taking one course, so we have 3 left. And say, based on the difference, we can take all 3. Then we take all 3, right? And then after we've taken all 3, like if we take a class, or we don't take a class. If we take the first class, what's the maximum number of classes we can take? Which means at 100, what's the maximum we can take for the remainder? If we don't take it, right, then what we're asking is, what is the maximum of these can produce? And yep. Each time we do this, it's gonna bifurcate, right? So it's like with 100, if we take the second class, if we take the second class, then we add 300, and we have 2 classes left. We have 2 classes left. Then how much? If we don't take the class, the second class, then we have 2 classes left as well. They're the same, right? With different conditions. And 300 we have, because we either take it or we don't take it. And 100 we can also have, that's the exact same situation, that we take it or don't take it. And this is 3. We take it, then we add 200. And then which means 200, try to find how they react. So 300, I cannot take this, but I can take this. And 300, same thing, cannot take this and take this. I don't see a dynamic programming here. Yeah, it cannot be like add them together. Add them together, like I say, 200, 1,000, 2,000, they add them together and we get 3,200, but we cannot do that because it just, oh, actually it does work. I'll have 1,000, I can take a 200, that give us 1,200. We can even take a 200, and take a 1,000, that gives 1,200, and then take this, we can take 3 courses. There's more than one way to find. With 200, 200 on the maximum extension, right? Maximum extension. So basically, we just want to say, if we sort it based on the last day, right? And just say if this makes sense, right? So the last day has to be, we have to take a class with a smaller last day first. If we take a large last day, I mean, it could be the same, right? But if it's the same, then both ways work. If it's not the same, then it will bust. Then it's likely if we swap it, it might work. If we swap it, that does not work. Which means if we swap it, and then here, plus we explode, then we reverse it, it will also not work. Yeah, let's see if this one makes sense. If we go small and a large, and a small and a large, it works. So we add a small, and then we add another one, which fits into the large. Now if we reverse it, we go large first, then there's a chance that it's not going to work. And if small and large does not work, so small and then large, we already burst, right? We already burst, does not work. And if we reverse it, it will also not work, right? It will also not work because if this amount plus, but basically if two durations we added together, right? If two duration we added together is smaller than the large one, but okay, if two duration we added together is smaller than the small last date, then we can swap them. It doesn't matter. If two duration added together is larger than the large last date, then no matter how we swap, it's still not working. Now, this only last situation is the two durations added together is in between the small last date and the large last date. If it's in that situation, then only the arrangement of small last date and then large last date works, because the other way does not work. Yeah, the other way does not work. Therefore, we say we need to go small first, small last date first. Right? If we have a chance to go small last day first, we should always go for it. So now we have established small last day go first. We can sort it based on that. And then what? Well, then we're going to say we can also take the smaller, so it's a small last day go first, and if the small last day, the last day is the same, then the smaller duration goes first. Because if I have smaller duration, and I have another one has a larger duration, and they have the same last day, and the smaller duration leaves more room for the next one to come. So in this case, we're going to sort the original. It's going to be 100, 200, 1,000, 2050, 200, 1,300, and we just check 100, 1,000, they're all good, 200, all good, plus this, That's 1300, and it explodes. We cannot do it anymore. And is that the optimal? Well, we have established that small last day first will always be better than big last day first. Yeah, so like that doesn't matter which one goes first, but it does matter in certain situations. So small one goes first, it should be fine. And then let's try. I feel like this is not correct, but I'm gonna try it first. I couldn't think of I mean, I haven't thought about it yet, so I'm not sure if there's a counter example. Like, it will be better to do this compared to do 100 or 1000 and then 200. Let's give it a shot. I have a hint, so I feel like this is not. I feel like this is not correct. But I want to see if there is a counter example. I really want to see. So my idea is we're gonna sort. Of course, we're gonna sort. Right? I'm gonna say t equals lambda top, and then we're gonna say top turn 1, and then top 0. Right? So that's the idea. I want to get a smaller row first. And then I'm going to say current time 0, and while current time is smaller. Actually, no. And I equals 0, right? While I smaller than len course, and current time is smaller or equal to courses I 1, right? If this is good, current time, initial time is 0, right? So we say 0 smaller or equal to the extend, and sometime it does not. And we are going to say what? I is index. We're looking at the first index and try to see if this one works. And now we say it does not work. I'm going to plus equal to 1. Okay. Let's say if it's good, then we say current time plus equal to courses I 0, right? And then I plus equal 1. Then we're going to return I. Yeah, it doesn't feel right to me, but I want to see like if this one will get anything that's wrong. I mean, the test cases might pass. So these test cases are not complicated test case. So it's very likely that the test case will pass, but not sure. I'm not using Vim at all, which I think is pretty bad. I should use Vim. But this is so much faster doing it this way. I mean, that's because you just don't have a good understanding of it, but if you do, yeah, it will be fast as well. 4, 3, right? And also, actually, we have to go here. Let's now do this, and I'm gonna go what? Here, insert. This one is 0. This, then go up. Oh, here, and nope, that's not what we want. We want just one letter. Okay. Okay, we have some issues. Of course, we're gonna go to the no, 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 no. We're gonna go up, and go to the end. End is here, and then we're gonna go back, Leet, yep, and then go down, Leet, go this, this, down, this, insert delete, this, go to end. We have to change courses, so we're gonna go down, 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 no, down, go up, and here is one gonna be courses, and go down one, and change to the end of word. It's gonna be schedule courses, and then go right. So this one's going to be courses. Name solution 3 is not solution. Yeah. Gonna go down to the end. Go view front. Delete this one. No, that's not correct. How is this not correct? I sorted first, and then I sorted first, which will give me 200, yeah, right? And then I said I0, I is index, and I say I is smaller than this, right? That's true. And then current time is smaller or equal to current time and smaller or equal to, we're always, now we added and always add 1. No, that's not right. It has to be no. Current time. I think it's gonna be doing it here. Right? When you do it here, current time first add this, and then we say if current time is smaller or equal to courses I 1, right? If this one satisfies, then we're gonna say I plus equal 1, and also in the break. Because it's only if it's possible, then we keep moving on. which also means if we go back here, we can say, nope, no, no, no. We're gonna go back to here, the end. Can we repeat it? Yeah. Nope. Oh, that should be B. Alright, current time plus equals, if current time is smaller or equal to the end time, then we say it's good. Otherwise, so it's bad. Alright, let's see. My projection is this one's having trouble, but I just want to see what type of test cases will cause this one to error. Okay, so this is the test case. So what we have 5, 5, and 5, 5, 4, 6, and 2, 6. All right. So we go 5, 5 first, and then we're gonna go 2, 6, and 4, 6. We take 5, 5, then we cannot take anything more. Okay, fair enough. Fair enough. So we take 5, 5, and we cannot take the next one. If we don't take 5, 5, then we can take the next one. So I think, shouldn't we also be, yeah, because if there's nothing left in between, no, that's not the way. That's not the way. Probably will pass maybe like a couple test cases. About the third test case. Now, yeah, this is not right. I feel like I just need to see a test case that can fail us. Okay, that's fine. That's fine. Which means five, and we used up, right? We used up all the quota. Not really used up the quota. We push the end time much further. The end time is 5 now. So should we also? No, it's not gonna be as simple as just figure out which one goes first. Hold on. Anyone we can choose to take this class. Right, we have a bunch of classes. We can choose to take a class or don't take a class. Right? If we take a class, then the remaining class is placed in a different situation. We take each class, right? We take each class and to see how the remaining feels. So like we take 5, 5, we'll see we add 5. So we have 2 classes left, but we have a 5 time point right now. If we take 2, 6, or if we take 2, 6, then we have a time of 2 left. Time of 2 left. Two, go 6, 4, go 6. So the ideal is to find an end time. We'll find an end time that can fit as many as possible. right? That's the ideal, to find an end time that can fit as many as possible. If we have an end time and we want to see how many can we fit. Like 1300 can fit 2, right? So 1250, 1250 coming in, how many can we fit into this point? Well, I mean, if we sort it, like 1250 goes first, and then we say 1250 can hold 2, and 1300 can hold all 3. So we say the maximum number of classes that can be held by any value, right? The maximum class can be held by any end date. So we say 1 is not gonna work. So 2 not gonna work. So 5. So if it maximum is 5, then we can hold 1 class, because 5 can hold, 2 6 we can hold, but 4 6 we can hold, but we cannot hold anything with them added together, right? Yeah, that's the idea. We cannot hold any of them added together. So if we know 5 can hold only 1 class, how about 6? Can we deduce something from 5? Now we say 5 can hold 1 class, right? And we hold, like, say, a list of classes. And then we want to know what 6 can hold. So the 6 can definitely hold 1 class. But what you want to see if it can hold 2 classes. Well, for 2 classes, it feels not easy to reason. We're having any combinations of classes, right? And should we go just taking classes, and then if it explodes, we just go back? It's like a backtracking kind of strategy. So it's like we take this, and then we'll take this, boom, cannot take it. So back here, try to take this that we can take, and then that's the end. Hold on. No, that still doesn't seem to be the right way of thinking about this. The right way shall be the maximum number of classes that I can take if involving the current class. Like the maximum number I can take involving the first class, right? And the maximum I can take involving the second class. And the maximum we can take involving the first class equal to the maximum we can take with a starting at 100 for 3 classes, right? No. Maximum I can take involving this. Maximum I can take involving this one. It gotta be like the maximum. So we can take this, so we can take something else, we can take something else, and if we have, say, 200, then we can only take the first one, right? And say we have 1300, how many can we take? So we just need to find the sum of the remaining the maximum number of sum of the remaining that adds up to 1300. No, that's not correct because they do fit 3200. Actually, they don't fit 3200, but they might fit, but it just like internally it doesn't work. Six. We have 2. Oh man. Remaining time slot. I can't think of any data structure that I can fit this one in. We have a certain end time, right? We have an end time, and then we want to see, and each one has its own end time. I want to see how we can fit everybody together. So first one is 5, 5, and then how to depict 2, 6. 6 is here, and then 2, 6 is going to be like this. And then I have 4 left, and then also 4, 6. If we say the largest gap, right? The largest gap, but it doesn't really make any sense. It has nothing to do with a gap. It has everything to do with a value that's very close, right? A value. Okay, put it this way. If we have a large gap, we have a small duration and a long end date, and those can be fit into anything. But they all work, right? So what does not work is when the gap is small, right? When the gap is small. So if the gap is small, and the value is huge. So what, we need to sort based on gap size? We sort based on gap size. If we sort based on gap size, still doesn't make any sense. All right, I'm not making any move. Let's look at the hint. At the current course, being total time of all courses taken to now, but adding a course might exceed my deadline. Or it doesn't. If it doesn't, then I have added one new course. Yes, if it does, so just a question of what happens if it does, right? We arrived here already. We can keep adding courses if it doesn't exceed my current deadline. And then that means we can keep adding course. But if we add a course and it exceeds the deadline, right, then, oh, I might have an idea. If adding a course exceeds my current deadline, then the only way of adding this course is we cannot take some of the course previously, right? We have to skip some course, some previously taken course, which is exactly what we want to find. So we have taken course, and then we have a course that exceeds our current deadline. And then we have two choices. If we don't take this course, or we take this course. So the idea is to find out the total number of classes that can be taken while we include this course versus we don't include this course. Then we can figure out the which way is better. What is the ideal, right? What is the ideal? The ideal shall be, if I include my current course, the ideal will be should be maximize the gap. No. Should be minimize. No. Yes. I think it should be to. Yeah. So either I add my current course. If I can, that would definitely add it. If I cannot add it, so there are two scenarios. Either we don't add it, right? So my current course is sacrificed. Or I add a course at my current course, but we're gonna take away some of the previous course, right? We're gonna do that. And when we take away, then we need to measure the fitness. Like what is the best outcome we want to achieve? Okay. So say we have 100, and that's good. Then we have 200, that's still good. Then we add 1,000, and boom, we have 1,300. Now we break our current deadline. So our choices is either take 1,000, then we have to ditch some of the previous class, or we don't take 1,000, right? So two scenarios. If we don't take 1,000, we have 300 is our current time. If we take 1,000, then we want to remove the most that have accumulated so far, which is 200. So we remove 200, and when we remove it, let's just put it back into the queue, right? So when we remove it, we are current at 1,100. And then, but we bifurcate, right? We bifurcate in this situation. And then we decide to take the next one. It could be 2,000. I mean, in this case, we definitely don't take the 1,000. And we take so that's 300. And we have smaller. Not sure. Let's go to that failed test case. 5, 5, and 2, 6. So we take 5, 5. And we want to take 2, 6, but it explodes. So we can either take 2, 6 and remove the one with the largest duration, which is 5, 5. So we end up with 2, 6. Or we remain 5, 5. We remain 5, 5. We have 5 versus 2. So we say 2 is better than 5. So we take 2, 6. And then we try to add another one. So if I 3, 2, and 3, 2 is a no-go already, because so every time we need to take a class and decide whether we take or not. And they say it's not, we cannot take it. If we can, we always take it. So if we can take a class, we always take it. And then if we cannot take a class, I mean, it's exploding. I mean, something in the past that needs to go, and then we just take away the largest. That one is gone. And when it's gone, it is actually, we just put it onto the back, because a rearrangement might cause it to fall in place. So we don't eliminate it. We just put it at the back. We just put it at the back, okay? Let's try this. If it doesn't work, we're going to try the other hint. I mean, this one we don't have any this one we don't have any sort. We don't have to sort anything. Right? So try this. Okay? So what we're saying is we're gonna just keep adding, and every time we add, we're gonna maintain a queue, a priority queue, and always return on the top is the largest. Yeah, the largest so far. And then we can remove it, put it at the back of, so I think we just need to turn this into like until we cannot go anymore, right? So we go 2000, right? And then we go 1000. And if we want to go 1000, we have to pop out 2000. Because 2000 is the biggest so far. So we'll pop out 2000. I'll get 1000 in. And then 2000 coming in. We can now go, we pop out 1000. That's a forever loop. When do we stop? Well, we stop when we... When do we stop? Because what we have is 100, 200, 1000 cannot go. So we say we pop out 200, right? So I have 1000. And we try 2000. It's no go. Push it back. And we try 200. Oh, we can go. And then we try, so we have 200 and we have 2000. And the 2000 trying to go, as no go, we can actually swap out 1000 out. So 2000 coming in, so it become, wait, can we even swap out? Yeah, we can swap out. We swap out, and 2000 coming in, and then 2000 works, and then 1000 is out, and then 1000 cannot go. So when do we end? I don't see an end condition in this. We just keep adding. If we pop it out, okay, we can pop it out, put into another queue, put it into another array, right? So basically we try to add as many as we can, and then we try to add from the other queue as well until we, it's the same thing. It's just, it constantly just swapping in, swapping out, swapping in, swapping out. What do we do? Like if we add one round, right, and then we have a bunch of things that currently getting swapped out, and then we have a value, and then we try adding them again, and if adding them again results in similar things, then we add it, because every time we try to add, we're gonna say we're gonna swap out something. Okay, I don't think this one is working. Let me check the other hint. Swap current calls because it has biggest duration. Yes, that's my understanding. I have just reduced the current time, right? What pre-processing do we need to do? The swap is always legal. So we do a swap. So I was right in this sense, right? I was right that if current is too big, then we swap the biggest. And after we swap the biggest, remember we're doing a swap, right? It's not just adding, is it? No, we just adding the current, we take it out, adding the current, and what, we just say that class we do not take anymore, which is true, right? Because if we sort based on the last day, right? If we sort based on the last day, like what we sorted earlier, if we do that, if we sort based on the last day, and then we find something that doesn't fit, right? So it extends. So we want to pop out the previous biggest. We want to pop out the previous biggest, basically remove it, and add the current. And this one, it will always work because we pop out the previous biggest. I mean, we'll also have to check if pop out the previous biggest even works. If we pop out the previous biggest and then still doesn't fit, right? If it still does not fit, then this current class basically cannot be added, right? It's a choice, right? Whether we add it or we don't add it. If we want to add, then we have to pop out the previous biggest. And if we pop out the previous biggest, still doesn't work, then we cannot add the current course. And if we can, why do we always add it? Because we sorted based on the last day. So by adding the current, we are extending the last day. So I think it's always beneficial to do so. We are extending the deadline. So every time we add it because we want to extend the deadline. So if we don't add it, the deadline is always smaller. All right, and then actually it has nothing to do with the deadline. So why do we want to swap it out? Like, why would swap out be beneficial? Well, swap out will be beneficial because there's just no reason why swap out will be beneficial. Current coming in, and it has a longer deadline. That's based on how we think right now. All right, we just add the current one into it, and we see if we fit the deadline, and we add another one, see if we fit the deadline. If we're sorting based on deadline. If we sort it based on deadline, and also based on the duration, right? And then if it fails, right? If it fails, it cannot fit anymore. But we are sorting based on the deadline and based on the current duration, right? So we're setting up as the best scenario possible. And then we have something that doesn't fit. Now, when it doesn't fit, we can swap out the previous biggest one and see if it fits. I mean, there could be a situation where it still fit or it doesn't fit. If it doesn't fit, then this one we can be guaranteed that it does not fit. We cannot use it. So we just eliminate it. Keep looking at the next one. If this one does fit, what is the benefit of keeping the current one and not the previous one? Well, the benefit will be the difference. Like, why do we do the swap? We do the swap in order to increase the gap between the current and the deadline. Because we know the next one, the deadline will always be larger, equal or larger, right? So if we have a large gap for now, then we'll have a large gap for the next one. So it's more likely we can add another course. So that's the criteria, whether we want to add a new one or not. All right? Again, 5.5 and 2.6, right? The failed test that we have. Because after we sort, it's going to be 5.5, 2.6, and 4.6. And we have 5.5, right? Which means the gap currently is 0. And we have 2.6. Now 2.6 cannot do because 7 explodes. So our ideal is we're going to swap out. We take this one out, right? And we'll take this one out. We say we take 5 out. So currently, so the new end time is 2. So we will have, after this operation, we will have the gap become 4. And a 4 gap is bigger than 0. So we say this swap is correct. We want to keep this swap. Otherwise, if we after a swap, so again here, we're going to do this first. We're going to do 1,000, 1250, so we got 100, and then we have a 200. Now, the question is, do we add 200? Actually, we do, because one that's 1300. That's good. And currently we have 3, and our gap is 0. And now we try to add the next one, right? So gap is 0, and we are looking at 1300. Now 1300 plus this is not working. So we say we want to swap out the biggest previously. So the biggest previously is this. So we swap out 1000, right? And then we're gonna swap in 200. So it's 200 plus 300, 2300 with a 32. So that's actually a good swap. So we're gonna keep it, and then that's it. So we also have 3. Let's try this idea. So basically, this idea says we're still gonna say courses sort lambda tuple, right? When we return tuple 1, and then tuple 2. And then after we sort it, right? After we sort the course, we're just gonna go one by one, right? One by one, and we also need a queue, right? So we need a say from import heap queue. We want to know the biggest so far that we have encountered. So we have this, and then we say heap equals this, right? And then we say for duration and last in courses, right? And we need to have current. So we say current time is equal to 0, right? So we're gonna say for duration and last course, whether we add it. So we're gonna say if we add it, right? So if we add it, we're gonna say current time. So current time plus equals to duration. That's the current time. And we say if current time is smaller or equal to last, then we say heap queue dot heap push heap, and then we're gonna push in this. What do we push in? Minus duration, right? And last. That's what we push into the heap. Actually, just the duration I think is sufficient. So all we need to know is the duration. Yeah, all we need to know is duration. I think we don't only need to use duration, right? So we're gonna push in the heap queue because current is working. Right? After pushing, thinking we are good, we can just go on to the next one. Now else, if current time is larger than the something burst. So we need to say pre, right? Pre equals, and we say, what do we say? We say if heap, right? Elif heap. If heap has something, then we can do something, right? So we say if elif heap. If heap doesn't have anything, then don't do anything. Okay, let's say else. Right, if we have a heap, then we need to take out the largest in the heap so far. So we say if heap, and then we say max duration equals heap q dot heap pop heap, right? So we're gonna pop the max duration out, and then we're gonna say if, so current times already have my current duration, right? So we say if the current time minus max duration, current time minus max duration is smaller than last, right? Smaller than last, and so current time minus max duration. The current time and minus max duration, the previous max duration. And we always max duration, previous max duration, and then we have how do you determine the current gap? Duration and the last, right? And then we say current time and current deadline, right? It'll be current time and current deadline. And then no, it doesn't matter. Again, the current deadline doesn't matter. What matters is if we swap, will it produce a larger gap? No, it shouldn't produce a larger gap because the ones we take out is always smaller. Oh, that's not true. That's not true. The one we take out could be larger. So basically we say current time minus max duration, we have a value, right? If it's smaller than the last, right? And then not only does it smaller than that, but also it's going to be smaller than so current time. Current time, well, I already added duration, right? So current time minus this is smaller than last, and current time minus max duration is going to be smaller than current time minus duration. And that is without swap. This is with swap, right? So all we say is if this n, current time minus max duration, smaller than current time minus duration. So this is swap. This is without swap. If swap can produce a bigger gap, right? Current time will be smaller, then in this situation, we are going to swap, right? We're going to swap. How do we swap? We say to swap. Basically, we just add the current. Yeah, we just add a current duration, and so we say current time minus equal max duration, and heap q dot heap push heap minus duration. So this is we swap, right? If we do not, right? If we do not, this makes me feel that it's not good in here. I'm actually going to delete this and say plus duration is smaller, right? And then we say current time plus equals duration. Else, which means it's larger, right? Then we say max duration previous, and this plus duration minus max duration. That's how we do the swap. Smaller than that, and then we say current time plus duration, right? Minus max swap, smaller than without swap. Well, without swap is just current time without swapping. And then we say current time equals, right? So we're gonna go here and do this equals current time minus max and plus duration, right? That's a swapping, and after we swap, we put this in. Else, right? Else, which means either current time, either the swap does not make sense, right? The swap does not make sense, or after swap, we're not reducing the gap. When that happens, that means we do not swap, right? We don't swap. So we're gonna put the max duration in, and we don't change the current time, right? So we're gonna say else heap q dot heap push. We're gonna push it back. Max duration, right? We push it back because we know swapping is not working. If not heap, if heap is empty, then we also, well, if heap is empty, we don't do anything because there's nothing to swap out. So we're gonna do that, and at the end, we're gonna return. Basically, I think we're gonna return length of heap. That's the maximum number we can keep inside. Sort takes no position. I forgot a key, so I'm gonna go here. Insert no. Insert key equals list out of range. Okay. Oh, of course, list out of range. I don't know why I do it. This is to be 0. He push 2 arguments. Okay, so 22. Actually, we're gonna have to go to front. Heap. Okay, so also try. Then we have a test case of 5, 5, 2, 6, no, 4, 6, and then 2, 6. This one will give us a 2. We still return 1. How is that possible? So duration last, 5, 5 come first. current time plus 5 smaller equal to this. We add it. Current time, I'm going to add to this. Yes. Next one coming up is 2, 6. Well, 2 plus current 5, no. And if heap, and the max duration is 5. Oh, did you mess up? Yes, I did. Yes, I did big time. We're going to go to line 18. So this one is not a, this one is supposed to be a minus. The duration is no, not here. It's not this one, it's this one. So it should be plus because max duration, oh, hold on. We just need to do this one, right? Nope. It's minus. Then max duration will be positive. And we also need to do 22G, and find this, and A. Okay, we're going to go one more. A is going to be minus. Okay, we pass. Let's try, see if this one works. If it doesn't work, we're going to check the result. Everything feels very fuzzy. You know, it's just, I don't know. I just don't feel everything is, we're correct. We're correct. I mean, what should I say? I should put a hint. We did look at the hint, but like all the hint stuff, it was in my head already. Like I'm not completely relying on the hint. Like the hint I considered, but I wasn't sure that is way forward. I think it has been this way for a while, right? It's always like I know how the approach, but just like there's slightly something there. I'm not quite sure. And also, I spend a lot of mental capacity just to understand how Vim works. Yeah. So the ideal is we're gonna sort it first, because the best scenario will be smaller gap, smaller deadline first, and then also smaller duration first. That's the best scenario. And then when something bad happens, then we need to swap out. Not really swap out, we need to take something away, right? Now we need to take the one with the biggest away. And when we take it away, we want for the remaining to have a big gap, right? That's the idea, to have big gap. Yeah, to have big gap. If we have a big gap, that means we can afford more. So because we did another analysis that the large deadline is always better to have the large deadline after the smaller deadline. We have this idea, large deadline should be after the smaller deadline, right? And then also if the deadlines are the same, then the smaller duration will be better because it produces a bigger gap. And then as we iterate through them, we need to find it like opportunities when we need to swap. We need to just drop one of the classes and include the current class. And the only reason to do so is to increase our gap, right? To increase our gap. And so the whole idea is to maintain our gap as big as possible. So we can go to here and try to see what we can say, right? So what we can say is the sort we first, okay, this solution is based on hint, although I have basically the same idea as the hint, yet I was not sure to pursue the idea illustrated in the hint. So the first task is to sort courses. We sort based on last day. It can be proven that having a large last day after small last day is a better strategy than the other way around. This is because if current time plus duration fits in both the small and large last day, then their order doesn't matter. Similarly, if current time plus duration does not fit in either the small or large last day, their order doesn't matter. It only matters if one of the last day fits, and this apparently, one of the last day fits, and the only if the small fits and the big, right? So if the small fits and the large also fits, right? No, I shouldn't say that like this. So it only matters if one of the last day fits, right? And apparently it can only be the large last day that fits, and the small last day doesn't fit. In this scenario, if we do the large last day first, then we are guaranteed to only fit one course. However, if we do the small last day first, then there is a chance that we can. It's not a chance, it's guaranteed. Yeah, then it's guaranteed. Then it's guaranteed. Then it is guaranteed that we can fit both courses. Therefore, it is always better to have to sort the courses based on their last day. If the last days are the same, we want to have the smaller gap and have smaller duration first, because that can produce larger gaps between the end of the class and the last day, which provides higher chance of fitting another class. The key idea from the hint is to iterate through the sorted classes, sorted courses, and when a course cannot fit, we check. Okay, we check whether it is a good deal to drop one of the courses with the largest duration so far. Yeah, to drop one of the courses with the to drop the course, to drop the course with the largest duration. Right, to drop the course with the largest duration so far. Right. The check is based on whether the drop can fit the new deadline, the new last day, and whether the drop leads to bigger gap between the end of the current course and the last day. If both conditions are satisfied, we do the drop. Right? We do the drop. So to obtain the largest duration, so far we use a heap queue. So what is the runtime? Now the runtime sort is O(n) log n, and this is O(n). Each time the heap is log n, so it is O(n) log n. So I think we can just say it's O(n) log n, right? And I don't know what's the time that we run at. That's pretty bad. 732 milliseconds. I think the actual one will be better. 31% ranking. All right, let's check the results. Yeah, this one based on hint. I don't like it. We have been like kind of softly based on hint on many of the problems. I think it's a medium. It's definitely a medium, but we didn't do very well in this medium. It's a hard one. Okay. Is that a consonance for you? I guess it. I mean, it is a consonance because we definitely didn't expect this to be a hard one. Okay, so this is LeetCode, what, 630. I don't think I've done this before. I think this is the first time. Yeah. Brute force, not going to work. Recursion with memorization. Iterative solution. O(n) squared. I don't think priority queue O(n) log n. Try to understand. Alright, we just need to, I think, make it bigger, and then all the code will work. Alright, recursion with memorization. How do you do recursion with memorization? The memo array size is filled once. Here n refers to the number of courses. And B refers to the maximum value of the end day from all the end days in the courses array. So they sort based on gap. Oh no, not gap, it's the end time. So when the schedule course, that's very easy. Memo is a 2-dimensional array with a course and course dot length -1. What's this? Rows are the courses. What about a column? Column is what is this? Course dot length -1. Oh, that's the largest. That is the largest deadline. Okay, so what we're trying to do, we're trying to say at each deadline, what is the maximum number of courses that we can take for each course. I equals I, what's I? I is the course, and int time, I think that's current time. That time the deadline, right? Time the deadline. If oh yeah, I was like, what the hell? It doesn't show the rest. Okay, if we memo I time, which means I is the another deadline. I is time, so current time, right? Current time. If we have the current time and we involve this course, like how many? If we involve this course and we have the time is at this, how many courses we can take, right? And then we say if time is current time plus the duration smaller equal to this, that means we can take it. So we can taken equals, this is the key, taken equals 1 plus courses schedule, right? So it's schedule courses. So this is taken, right? If we taken the course, or if we don't taken the course. So if we take the course, yeah, this is like we either take the course or don't take the course, right? If we take the course, then the number taken will be we take the course plus the maximum courses we can take with the next course, right? This is the next course, and our current time move forward, right? So that means at this timeline, the starting time, okay, at all the starting time, if I take this course, how many courses we can take? And if we're not taken, then if we don't take the current course, then the maximum course we can take from current point going on is the next course without including this. That is correct. And then memo I time is at this course, at this current time, how many courses, what's the maximum number of courses we can take, which is either taking this or we don't take it. So it is bifurcate, right? So every time we either take or we don't take. but we use a memorization so we can reduce the amount of computation. And then we return this. I should have been able to come up with this one. I was almost, but I look at D. These are 10 to the 4th. All right, I just got scared. But that is true. At any time point, okay, this is actually a good one. We can do it iteratively. Yeah, if you can do it this way, then you can also always do it iteratively. It's gonna be very complicated. I want to try it. I don't feel right. It doesn't feel right. Like I shall be able to get this. Optimized iterative. Of course, array itself, so the first count elements. Priority queue, stomachache. Traversal of the course which have been taken to find the course which can be replaced by the current course. These traversals can be saved. The use of priority queue, which contains duration of all the courses. Now the current course can be taken, it is added to the queue, and the value of the current time is updated. If the current course can be taken directly, as in the previous approaches, we need to find a course whose duration is maximum from amongst the course taken to now. Now, since we are maintaining a max heap queue, we can obtain this duration directly. We can replace jth course with the current one. Thus, we remove the duration from the queue and add a current course duration to the queue. We also need to make proper adjustments to the time to account for this replacement. At the end, the number in the queue represents the number of courses that have been taken to now. I think it's slightly different. Like I have this condition to determine whether to do it. I don't think they have this condition. This says we always swap. How do we always swap? What if we cannot swap? Or is that not going to happen? Yeah, we sorted. Yeah, we does sort it from small to big, right? And then we say time plus the current course is smaller than this. We put in the queue, current time increment, elif if q dot peak is larger than C0. Oh, the larger than C0. Oh, we only get it out if the current is bigger than C0. It's like the current duration. Oh yeah, we always as we go through what we want. So we already sorted. Right, we sorted, so the last day, the deadline is increasing, right? But what we want is also the duration to be increasing. Right? We always want to have the smallest duration so far. That's the idea. So every time, if we can fit, we always fit. If we cannot fit, then we take the biggest out, and then we swap in. And it has to be the biggest is bigger than the current offering, right? Have to be bigger than the current offering. If it's bigger than the current offering, then when I swap out, then we will definitely fit. Because current, I don't fit. If we minus this, minus the largest, then we always minus. What if we still doesn't fit? I think it's possible, right? The biggest one, if the biggest one and the current one is very close, right? And then by swapping out, we only increase the gap by a little bit. And if we still cannot, well, because we sorted already, right? We sorted already. If we sort, then it appears later, then it has there's a big gap. It has to be a big gap, right? Because of the big gap, if we add a current one and it overshoots, I think the one that we can remove, I don't think so. I think we still need to check, although it might be correct every single time. And we don't even check on the gap. I might have to read the other solutions first. Okay, so iterative. So basically, is whether we want to take a class or not take a class. If we take a class, or if we can, we always take a class. If we cannot, then we can decide whether to take a class or not take a class. Right? If we can, we take a class. Now we always do take a class or not take a class. For every single one of them, we either take or we don't take a class. So, and what we want to know is, yeah, I understand this one. Let's see the iterative. Based on the end days. As we consider the courses in the ascending order of their end days, we keep track of the current time. Along with this, we'll keep track of the number of courses taken to now in count variable. For each course being considered currently, we try to take this course, but to be able to do so, the current course should end before its end time. Alright, sorry. Can be taken, we take it, but if we are not able to take it, try to take this course by removing some other course from amongst the courses that have already been taken. But the current course can fit in by removing some other course only if the duration of the course being removed is larger than the current course duration. That's true. If it's smaller, okay, why? If the current taken course is smaller, we're sure of the fact that by removing it, we can fit in the current course because course J was already fitting in the duration available till now. Yes, it's fitting. It's fitting now, and then we want to add a new one, and we have a bigger, remind you, we have a bigger deadline. So if my current duration is smaller than whatever duration we have taken before, then it must fit the previous deadline, which will automatically fit the current deadline. That is correct. That is correct. That is correct. But if it's smaller, then it's not likely. It's not possible. It is possible, but it's not likely. It's not likely. So it has to be bigger. And if it's bigger, if the largest is bigger than me, right, then swapping it will produce will reduce, right? We definitely reduce. Yeah, the gap gets bigger. Yes, the gap gets bigger if we swap the largest. If the largest is also bigger than me, that's true. Should I take its place? Of course, from month. But why are we doing this replacement? The answer is followed by replacing jth course with the ith course of a relatively smaller duration, increase the time available for upcoming courses. An extra time can be made available. Yeah, we increase the gap. Course taken for the replacement should be the one with the maximum duration. Thus, from the amounts of courses that have been taken until now, we find that courses having duration, it should be more than the duration of, let's say, the course of max I. Thus now, a saving of this can be achieved, which could help later in fitting more courses. That's true. Remove this course from the courses. Also mark this course with -1 to indicate this course has not been taken and should not be considered in the future. If the course isn't found, we can't take the course. Let's mark. Okay. So it's exactly the same idea, right? It's the same idea. I don't know how you make the extra list even helpful. It's definitely a priority queue. Like it's 100% a priority queue, but we can do a better, right? We can do a better priority queue. Yeah, I mean, the mental image should be like this, right? We have these courses, and we want to sort the last day. That's for sure, right? After we sort the last day, our mental image should be we want to just try to take the classes with the smallest duration as possible. So if we iterate through, right, if we can fit, that definitely fits. We fit everything, right? If we cannot fit, once we cannot fit, what do? We just swap. And every swap, we want to make it more inviting, right? More inviting to future. So in the swap, if everything in the previous is not bigger, they're all smaller than my current one, right? Then the swap is a worse. If you think about it, the swap is a worse. If the previous, because if none of the previous is bigger than my current duration, and I swap, then after swap, our gap becomes smaller. Now that's why it worked in this solution, because I consider the gap, right? I have a gap consideration, so those that don't happen. But in reality, we shouldn't even consider the gap because it's not necessary. It's not necessary to consider the gap. It's true, it's not necessary to consider the gap because the gap automatically becomes smaller if the biggest in the heap is bigger than the current. Okay, so we do this the same, and then this is the same. Else, if heap and heap 0 is larger than duration, what do? We say current time equals current time plus duration and plus heap q dot heap pop heap, right? And then after that, we'll put a duration in it, right? And this is going to be aleph oh no, Ooh, the last one is not correct. I popped it. Oh no. 71. Here, that's minus. There we go. Yeah, so this is a better solution. This is according to the solution. The idea, the key idea is to pop the max duration encountered so far if and only if it is larger than the current duration. This is because if the max duration is larger than the current duration, we can guarantee that the swap results in larger gap between current time and the last day. In other words, we don't have to check for it separately. Yeah, very good. This is very, very very nice. Oh no. Forgot I cannot have two. Should run it fast. I think I'll be faster. That's fine. Okay. All right, that's that. Recursion, DP, no cache, with cache, and with this. All right, that's it. That's it for this problem. I mean, we almost there. It's like for the past 2 days, maybe 3 days, we always like tantalizingly there, but this is lacking the last bit. And we have to always check the hint and kind of get a confirmation of where we are going is right. I mean, for this one, it's more hint. I mean, we're pretty far. We're pretty far. So again, after you finish it, you think back. It makes perfect sense, right? It makes perfect sense that we want to try to get the smaller duration altogether, and the only way to do so is just keep adding and then we swap. Yeah, it's very smart. But I think I should have been able to use the DP solution at least, right? Because I was thinking each class we can either add or we don't add, and then I just got stuck right there. I just got stuck. I should be able to figure out, like, if we add a class, right? We add the current class, then what is the maximum that I can do, right? Or if we don't add the current class, what is the maximum I can do? And of course, It all depending on whether we can add a class. Like if we cannot add a class, then it's a moot point, right? It's a moot point. So it's always about if I can add the current class. If we can add it, then the maximum class that we can take from this class onward, right? From this class onward will be 1 plus my next one. If I don't take the class, the maximum will be just my next one with different time constraints. And if we use a memo, this one shall be, yeah, I shall be able to come up with this one. I feel very ashamed that I wasn't able to. I was close, I was close on both solutions, the DP and the priority queue. I was close on both, but just lack a little bit of ingenuity at the end. I don't know. I mean, it's not a good streak. It's not a good streak. We're gonna make it clear that we used a hint. All right, that'll be it. That'll be it for today. I'll see you guys tomorrow. Adios.